Hello, beautiful people, and welcome. In this video, we are talking about the properties of rhombuses or rhombi. Now, a rhombus is a quadrilateral. What that means, it is a four-sided shape. And all of the properties that we've learned previously for parallelograms are included in a rhombus. So think of a rhombus as a special type of parallelogram. So just to review the properties for parallelograms, we have that opposite sides are congruent. So if we have this side here, looks like I didn't label, so I have A, B, C, D. So if I have CB, the opposite of that is DA, and those two are congruent. CD and BA are also congruent. So you'll see tick marks here and here, and you'll see tick marks here and there. Opposite sides and opposite angles are also congruent. So we have opposite angles here. We also have opposite sides are parallel. So you'll see these little arrows, these little tick marks, that represent parallel. Angles, opposite angles are congruent. So if we have angle C, that is congruent to angle A. Angle D is congruent to angle B. Consecutive angles are supplementary. That means angles that are right next to each other, for example, B and A, when you add them together, they equal to 180 degrees. C and B also added up equal to 180. C and D add up to 180, and D and A add up to 180. Diagonals bisect each other. So what that means is when you have diagonals, so we have a diagonal of CA and DB, when they cross, this point right here cuts each diagonal in half. So you have D, let's call this point P. So we have DP is the same measure as PB, and CP is the same measure as PA. Now, these are the properties of parallelograms. So in addition to all of that, we have these three additional properties for a rhombus. That means that all four sides are congruent in a rhombus. So 1, 2, 3, 4 sides are congruent. The diagonals are now perpendicular, so that means they meet at a right angle. Sometimes you're going to see this drawn as a box because you have 1, 2, 3, 4 right angles. All of this is 90 degrees, 90 degrees, 90, 90. And then diagonals bisect opposite angles. So what that means is the diagonals, these angles right here, opposite angles, the diagonal cuts each angle in half. So not only are opposite angles congruent, but now each side, so like this one and this one, are the same measure. Let's go ahead and do some questions and examples. For example number 1, given a rhombus BCED, what is the measure of CD, FD, EF, and EC? And I'm looking, and I hesitated there for a second, it doesn't look like they give us any measurements. So let's go ahead and put that in. Let's mark it up first. Let's mark it up, and then we'll give you some angle measures. So let's say we have a rhombus. So I'm going to mark it up with all of the tick marks that represent a parallelogram and then the tick marks that represent a rhombus. So for a parallelogram, we note that the diagonals bisect each other. So we have these two and these two that are congruent. Let's zoom in just a little bit. We note that the opposites are parallel. We also know that opposites are congruent. Now, we also know for a rhombus that all sides are the same. So I'm going to put tick marks here. Let's put 3 tick marks since I already used 1 and 2 tick marks. All of those are the same. We know that opposite angles are the same. We also know that they meet now at 90 degrees. That's a property of a rhombus. And that, I think that's it. Diagonals bisect each other, we already got it. I believe that's it. So let's go ahead and add some angle measures. This B is bothering me, so let's go ahead and make sure that looks like a B. Let's say this side is 13. Let's say this side is 15. Let's say this side is 9. So if we have these three measures, I'm going to choose a different color and we can label. If this side right here is 13, that means all sides are the same measure, so all of them are also 13. If this side is 9, that means this side is 9. If this side is 15, that means this side is 15. So let's answer some of the questions that they give us. What is the measure of CD? Well, CD is 13. What is the measure of FD? FD, this one right here, is 15. What is the measure of EF? E right here, and F, that is 9. And EC, well, EC contains 9 and 9, so that would be 18. My hint for any of these is to make sure you mark up your image before you start answering any questions. Mark it up, and then from your tick marks, it's easier to see what is congruent to what. Let's go ahead and find the measure of angle HGI. So let's mark it up. Again, this is a rhombus. So I have all four sides congruent. I know they meet at 90 degrees. I know that opposite angles are congruent. I know that consecutive angles are supplementary. I know that diagonals are congruent. Diagonals are not congruent, excuse me. Diagonals bisect each other, which means each side, this one and that one, is congruent, and then this little one and this little one are congruent. And I believe that is it. So let's go ahead and find the measure of angle HGI. So HGI is this measure right here. This guy right here. So unfortunately, I don't have any information on this side. I do have these two. So I'm going to see if there's something that we can do with these two pieces of information in order to find out what that is. I'm going to highlight this. I feel like my arm is always shown in this video, but that's okay. I'm gonna copy it down. So this is the triangle that I have right now. I have a 90-degree angle there. I know that this angle measure right here is 4x plus 3, and I know that this angle measure right here is 7x minus 1. Now notice that we have a complete triangle. Maybe I will shade it. It's this triangle right here. We have a complete triangle, and that triangle has a 90-degree angle because we know that the diagonals bisect each other, but they also are perpendicular now. So because it's a full triangle, we know that 7x minus 1 plus 4x plus 3 plus 90, that's all going to equal to 180 degrees. I'm going to subtract 90 both sides. 7x minus 1 plus 4x plus 3. You don't have to put parentheses around this if you don't wish. Equals to 90. I'm going to combine like terms. 7, 8, 9, 10, 11. I have 11x. Negative 1 and positive 3. That's a positive 2. I'm going to subtract 2 both sides. 11x is then equal to 88. X is then equal to 8. Now, we did solve for x, but it's not asking us to solve for x. It's asking us for HGI. So I'm going to take x and I'm going to plug that in here. And I'm going to see what each angle measure is. So we have 7 times 8 minus 1. That gives me an angle measure of 54 degrees. 4 times 8 plus 3. That gives me 35. And I'm just going to do a quick check. 54 plus 35 plus 90 does in fact equal, well, let's see, hold on. 90 plus 54 plus 35. For some reason, it's giving me 179 instead of 180. So I'm going to see what happened here. So 7 times 8 minus 1, that equals to 55. So not 54, 55. I did that wrong. So now 55 plus 35 plus 90 is equal to 180. I'm very happy that I checked. So if we know that this angle measure right here is 55 degrees, and we know that this angle measure right here is 35 degrees, we also know that because it is a rhombus, that the diagonals bisect opposite angles. So that way, this angle right here gets cut in half, this angle right here gets cut in half. So if this side is 35 degrees, then this side is also 35 degrees. And if this side right here, this side right here was 55, this side right here is 55. And then it looks like we have another right triangle here with 55 degrees, 90 degrees, and this one has to then end up being 35 degrees because we need 180 degrees. Then this side also has to be 35 degrees because it was bisected, it was cut in half. So because this one is 35 degrees, that is our answer to what the measurement of the angle HGI is. All right, beautiful people, we will do many more examples in our next video, and I will see you later. Bye!